Chicxulub crater, located in Mexico's Yucatan Peninsula, resulted from a massive asteroid impact that wiped out the dinosaurs about 66 million years ago. Although the experts have thought they knew the whole story about the impact, recent studies have revealed more terrifying details. The Chicxulub crater, which is 93 miles in diameter and 12 miles deep, is the second largest impact point on Earth. However, its peak ring, which is still intact, sets it apart from other craters on Earth. The asteroid, ranging from 6.8 to 50.3 miles in diameter, hit the Earth with an estimated force of 21 to 921 billion times that of the atomic bomb dropped on Hiroshima, releasing 100 million times the energy of the Tsar Bomba, the most powerful human-made explosive ever detonated. Geophysicists Glenn Penfield and Antonio Camargo discovered the Chicxulub crater in 1978 while searching for petroleum. The crater was buried beneath more than half a mile of sedimentary rock, making it difficult to study. Despite its age, the Chicxulub crater continues to yield new insights into the Cretaceous extinction event. Eventually, Penfield had to give up on his research on the crater because much of the evidence he was looking for was destroyed or lost. However, he published all the data he had gathered and returned to work. Meanwhile, other scientists had started theorizing about something similar even without having seen Penfield's research. In 1981, a graduate student named Alan R. Hildebrand and his advisor, William V. Boynton, from the University of Arizona, published their own Earth impact theory. They had plenty of geological evidence but needed to find a crater that could corroborate their hypothesis. Their work gained more traction than Penfield's, particularly after a professor in Haiti named Florentine Morris uncovered evidence that an ancient volcano had once stood in his country. Hildebrand realized that it could have emerged after a major impact had crashed nearby, and in 1990, he learned the precise spot of such a collision. In that year, a journalist for the Houston Chronicle named Carlos Byers informed Hildebrand of Penfield's findings, and the two experts later analyzed drill samples from an oil company's storage unit. Shock metamorphic materials were found amid the drilling debris, which appears after an impact-related event causes deformation and heating. Penfield and Hildebrand had uncovered something much bigger than a normal case of shock metamorphism, and subsequent research into the Chicxulub crater has led to new theories about its origins. In September 2007, authors William F. Boake, David Bakralishi, and David Nesburney offered a theory to Nature magazine that the rock responsible for creating the crater came from a specific cosmic family called the Baptistina asteroids. However, new evidence released in 2011 negated their claim. Nonetheless, the discovery of the Chicxulub crater lent credibility to a theory first formed by physicist Luis Alvarez and his geologist son Walter Alvarez, who believed that between the Cretaceous and Paleogene periods, a massive impact on Earth had triggered a series of animal and plant extinctions, including all non-avian dinosaur species. In 2019, drilling into the Chicxulub crater revealed evidence of a terrifying geological post-impact world, with rocks behaving like a fluid for a brief period of time, consistent with the dynamic collapse model theory, and tsunamis and wildfires caused by the asteroid's impact. Chodas was the person who first noticed that the object observed in 2020 was not a typical asteroid. However, he was uncertain about what it really was. Chodas heads an organization that has an important mission of observing the skies to assess the trajectory of asteroids. The Center for Near-Earth Object Studies is responsible for issuing warnings in case Earth is in danger of being hit by a dangerous space rock. However, the object spotted by Hawaiian researchers could be space junk, which comprises thousands of debris pieces left in the planet's orbit since humans first started observing the skies. Some of this debris includes fragments of paint, pieces of launch rockets, and approximately 3,000 redundant satellites, with millions of smaller pieces of trash. Abandoned or lost equipment at lower altitudes burns up in the atmosphere, while the pieces of junk higher than 22,000 miles above the planet's surface remain in pointless orbit for centuries, and new satellites could even collide with old dead ones. CODIS had ruled out that the object was an asteroid because of the unusual path 2020 was taking, and using a computer simulation, he threw the simulation into reverse to determine the object's origin. The simulation showed that the object had been close to Earth in 1966. This theory led to the conclusion that the mystery object could have been part of the NASA space vehicle Surveyor 2 mission, which went wrong. Surveyor 2 was launched in September 1966 with the task of beaming back photographs of the lunar terrain, but one of its 3 booster engines malfunctioned, pushing it into an uncontrolled tailspin and losing communication with Earth. Mike Dinh, the deputy director of the monitoring station, recalls the optimism surrounding the 1966 launch and how Surveyor 2's failure was unexpected. The process of studying the peculiar flying object began, with the aim of identifying it positively. This was a challenging task due to its size of approximately 25 feet and its location thousands of miles away from Earth. Researchers in Arizona and Spain confirmed that the object, named 2020 SO, was not a naturally formed asteroid. The path of the object was being subtly altered by the radiation from the sun, which would be unlikely if it was a solid rock, but expected if it was a hollow piece of metal. This led to speculation that it could be the remains of a booster rocket, particularly the Centaur rocket section from the Surveyor 2 mission. State-of-the-art technology was used to analyze the object's composition, which was found to be metal rather than rock. The data captured by an infrared telescope in Hawaii was compared to that of 301 steel, the material used in Centaur rockets. Although the match was close, more precise measurements were needed for a definite identification. A further step was taken by comparing the spectral data from another Centaur rocket booster that had been in Earth orbit for many years. This was a challenging task due to the extreme speed at which Earth-orbiting boosters travel across the sky. However, the scientists succeeded in getting a solid and reliable data set, and the analysis confirmed that the object was indeed the Centaur booster rocket. Despite initial speculation that it was an alien spaceship or an asteroid, the identity of the object was confirmed as space debris from the Surveyor 2 mission. The Centaur booster will pass beyond our planet and head off on its orbit around the Sun in the spring of 2021. It is expected to return towards Earth in 2036. Subscribe to the channel for more updates.